My name is Scott Onstadt, and I'd like to welcome you to AutoCAD 2016 Essential Training. AutoCAD has been around for over 30 years and is the industry standard for computer-aided design. People use AutoCAD in many different professions and disciplines. In this course, we will start at the beginning, drawing lines, rectangles, circles, and other geometric objects. We will then learn many tools to manipulate these objects and control their visibility. You will gain experience in practice projects. You'll add to your knowledge step by step with topics such as hatching, dimensioning, annotation, attributes, tables, external references, layouts, and creating output. We'll cover all of these tools and more. So let's get started with AutoCAD 2016 Essential Training. If you are a premium member of the lynda.com library, you have access to the exercise files used throughout this course. These files can be found on the Exercise Files tab on the main course page. If you go into the Exercise Files folder, you'll find that the content is organized by chapter. In each chapter folder, you'll find a number of drawing files, and in some cases, there are image files also. You may notice that from chapter to chapter, sometimes the file name is repeated. Take care not to transfer the files between these folders. If you want to make changes to these files as you're working, I recommend that you change the name to My Architectural, for example. That way you can keep track of which ones you've altered and which ones come with the course. If you don't have access to the exercise files, you can follow along from scratch or with your own assets. Let's get started. In this video, we will tour AutoCAD 2016's user interface. When you first start the program, you come to the Start tab, and in the middle you'll see a list of recent documents. On the right, there's a notifications area which you can scroll down for more information. Down below, there's a Connect area. If you click this icon, you can log into A360, where you can store drawings in the cloud. Down below, there is a Learn page, which contains a list of videos which ship with the program. I'll go back to Create. And over here on the left, you can choose a template to begin drawing, or you can just begin drawing from scratch by clicking this button. And that's what I'll do. This launches the full user interface. At the top, we have what is called the Application menu. Click to open, and move the cursor over these items without clicking. And you'll see that they automatically change, and you have items you can choose over here on the right. There's a search bar up here where you can type in command names. So for example, let's say you've heard of the command fillet, but you don't know where it is in the interface. This will give you information about where to find it. There are actually two different versions of fillet. One's a 2D version, and there's a 3D version down here. So for example, let's say I want to find this command in the interface. It's on Ribbon tab Home, the Modify panel, and it's in a chamfer and fillet dropdown. Let's see if we can find that. This is the Ribbon tab Home, this is the Modify panel, and this is the fillet and chamfer dropdown. If you hold the cursor over a command, you'll see its tooltip, which gives you more information. Some panels can be expanded like this one, and you can see that with a downward-facing arrow. That means there are more commands available, each one with its own tooltip. There are many tabs on the ribbon, and some of them have drop-downs, and you can just go through here and examine how some of the content is organized. You can also rearrange the ribbon using workspaces. Go down here and click this icon and choose the 3D Basics workspace. That changes the content of the ribbon. Everything is a bit different now. The idea here is that the tools relevant to 3D modeling are filled into the ribbon. When you want to go back to drafting, you just select the Drafting and Annotation workspace. Notice though, when I do that, it opens up this floating palette called Design Feed. Let's close that for now. Continuing on with our tour, this top area is called the Quick Access toolbar, and it has common commands such as new, open, save, save as, plot, undo, and redo. And you can add or subtract items from this menu using this drop-down. Say I want to add workspace to the list. That will give me this drop-down menu, which allows me to change workspaces up here as well. Here you can type in command names or phrases to search for them in AutoCAD's help system. Over here, this shows my user account on A360. This is how you can access apps that work within AutoCAD to extend the functionality of the program. Over here, you can access Autodesk's online community, and this is a link to the help system. Of course, over here we have the standard Windows controls for the entire application and a corresponding set of Windows controls for the current drawing. This whole area is called the drawing window. This element is called the view cube, and it helps you navigate in three-dimensional space. The navigation bar contains a list of common navigation commands that are used both in 2D and in 3D work. These are the in-canvas controls, and they're actually menus. You can open them just by clicking on the word. You can also right-click to open the context menu, and the information that's displayed in this menu depends upon the context in which you are clicking. So if I right-click up here, I'm going to get a different menu. If I right-click here, I'm going to get a different menu. You see? It's context sensitive. This is called the user coordinate system icon. I clicked it, and now I'm going to press escape to deselect. This is called the command line. If I type in a command, such as fillet, you'll see that autocomplete will sort through an alphabetical list of commands, which can save me a few letters of typing. I can click on this to execute the command. And now it's running on the command line. You see the prompt here and some options. I don't want to dive in too far in this first video, so let's cancel out by pressing escape. Down here we have model and layout tabs. I'll click on layout 1 to go to this virtual sheet of paper, which is where I would lay out the drawing for plotting. You can also hover the cursor over the File tab to go to the different layouts or to go back to model space. Alternatively, you can just click these tabs down below. They do the same thing. Finally, over here in the lower right of the interface, you'll find the status bar toggles. They're on when they're blue and off when they're gray. And each status bar toggle has its own menu. You can access that by right-clicking. This goes to a dialog box. This one opens up a menu instead. Each one is different. You can also add or subtract items from this menu by using this rightmost button called Customization. Here you can add, let's say, line weight, and you see that when I toggle that on and off, it's adding this element right here that allows me to show or hide the line weight. I'll just turn that off again. This completes our tour of AutoCAD 2016's user interface. The ribbon gives you visual access to most of the commands used in AutoCAD. In this video, you'll see how to customize its appearance using the ribbon's 3 modes. So the ribbon is organized into tabs, panels, and commands. You can display this information in different ways using this control right here. Click on it one time, and you will change the panels into these icons. You can go to another tab, and then hold the cursor over the draw icon, and you'll see all of the commands on its panel appear right here. If I click this button again, we'll minimize to panel titles. So this saves room on the screen. I can then position the cursor over the word draw, and I see that same panel. I'll click on it one more time, and we'll go to the most minimalistic view where we simply see the tabs. I'll click on the tab, and that opens the full ribbon temporarily, so I could select a tool, click on line, and start drawing a line. But when I do that, the interface disappears. Click on it one more time to cycle back to the full ribbon. And that keeps the ribbon on screen all the time. And that's the way I'm going to be working in this course. In the next video, you'll learn about changing workspaces. AutoCAD's user interface is highly customizable. To give you a feeling for this, I'll show you how you can use workspaces to change the content of the ribbon. You can access workspaces in two different ways. One, use the Quick Access toolbar, and two, use the status bar. I'll show you both methods. Click this downward-facing arrow to open this Customize Quick Access toolbar menu, and then choose Workspace. This adds a new drop-down to the toolbar. I can then open it and select 3D Basics. This changes the content of the ribbon. It gives me a few 3D modeling tools here on the Create panel, and some Boolean tools on the Edit panel. I still have some of the drawing tools available here and modification tools here, and those were available in the original workspace. But things are rearranged here according to the task at hand. So if I want to do a little 3D modeling, I might just switch to this workspace. It's not necessary, but it makes things a little quicker and easier to find. AutoCAD is fundamentally based on commands. So if you remember the command name, you can type it in. But if you've forgotten the name or remember it by its icon, you can find it visually in the ribbon. Another way of accessing workspaces is down here on the Customization button. Click that on the status bar and choose Workspace Switching if it's not already selected. Then click this gear icon to open a pop-up. Here are those same three workspaces that ship with AutoCAD. I'll click Drafting and Annotation to switch back here, and the Design Feed palette opens up. I'm going to close that by clicking its X icon right here. Now, every time I switch back to this workspace, that palette is going to appear because it's saved in the workspace itself. I'd like to turn that off on a more permanent basis and only call for it when I need it. And to do that, I'm going to open up the Workspace menu and select Workspace Settings. Here you have the option of whether or not you want to save changes to your workspaces. You have to choose this radio button if you want to save the changes and click OK. Just be warned that anything you do now is going to be recorded in that workspace. That is, any changes to the user interface will be saved in the workspace. So if I now switch to 3D Basics and then switch back to Drafting and Annotation, that will leave the Design Feed palette closed. It doesn't reopen it like it did initially. Now let's say I want to pull up that palette. I can just type it in. I'll start typing Design Feed, and as I do that, watch what happens. DES, and autocomplete narrows down the commands that are available as you go ahead and type. So I want to reopen that by using Design Feed Open. So I'll just press Enter now, and sure enough, that opens the palette. I can close it with a close box. You can also go to the View tab, which is present in every workspace, and here you can toggle on various user interface elements or turn them off. I'll toggle off the navigation bar, the view cube, and the UCS icon. I'll also toggle off the layout tabs because the same functionality is available on the file tabs here. Just by holding the cursor still over a file tab, you have access to model and the layouts. This is just my personal preference on how I like to have my workspace cleaned up so I don't have extra user interface elements on the screen. But as you can see, AutoCAD is highly customizable, so you can adapt it to the way that you like to work and the types of things that you're doing. In the next video, I'll show you how to get into the nuts and bolts of how to customize AutoCAD's user interface. In this video, we will relocate a command on a panel to get a sense of how far you can take customizing the user interface. In the Drafting and Annotation workspace, go to the Home tab and then click on the word Draw here to open this slide out. This reveals additional tools. This command right here is multiple points, and the command that you would type on the command line is shown at the bottom of this tooltip. It's point. I'd like that command to appear to the left of the line command here in a large icon form. Let's take a look at that. Type in CUI for Customize the User Interface and press Enter. That opens up this large, potentially intimidating dialog, but I'm just going to give you a quick tour of this and just give you a sense of what's possible. I'll go into the ribbon here in the hierarchical tree and open up Panels and scroll down and locate Home 2D Draw. Open that and then open up row 1 and row 2. So we have this listing which corresponds to what we see over here. I want to move multiple points up into row 1. So basically I want to move this command over here. So I do that by dragging this up in this hierarchy and dropping it right above the line command, right there. And now the icon appears in a new location. However, it's too small. So we can change its property right here. The button style, I'll open this up and choose Large with Text Vertical. And there we have it. Now it says multiple points. However, multiple points kind of takes up too much space. So I'm going to remove the word multiple and just say points. And then I'll click Apply and OK. And in a few moments, the change will take effect. There we have it. Now it says points and line. So we've successfully customized the user interface. So I don't really recommend that you go changing everything right in the beginning, but I just want to give you a taste of what's possible and how you can customize AutoCAD to suit just about any purpose that you have to use the software. In the next video, I'll show you how to edit command aliases. Most commonly used commands have command aliases or abbreviations you can use on the keyboard. For example, you can type REC instead of the full word rectangle to save time typing. In this video, you will edit a command alias using the alias editor built into AutoCAD. Type alias edit and press Enter. That opens up this dialog box, which is really a front end for editing this acad.pgp text file. One of my pet peeves with AutoCAD is that the standard command alias for the copy command is CO. And I use the copy command. It's probably the most frequently used command in AutoCAD. And I don't want to have to type in 2 letters. I just want to type C enter. And so I'm going to change that here and show you how to do it. So CO is copy. So I'm going to click Edit. I'm going to change that to C. OK. And when I do that, we have a warning because there's a duplicate. The alias C is already being used for the circle command. Do I want to redefine it? In this case, yes, because I copy things more than I draw circles. So when I do draw a circle, I don't mind typing CI. So I'll say yes. The alias C now refers to copy. Great. Let's go back in the alias editor one more time. So I'll just press Enter to repeat the previous command. And that just brings it right back up. And then I'm going to scroll down this list until I find circle. And right now it's also C, which is potentially a source of a problem. So I'm going to edit that and make that say CI so we don't have a conflict. OK. And then I'll click Apply. I'm going to overwrite this file, and you can see where it's located here in this long path. And alternatively, you can edit that file using Notepad or some other text editor. Just make sure you don't save it with any formatting. It's just a simple text file. I'll say OK and OK again. Lots of OKs here. And I've experienced this a few times where AutoCAD thinks that it's crashed. You just cancel this. It's actually fine. Now I'm going to type C, and it says circle. Seemingly didn't work, but I think what we need to do is close out of the application and relaunch it. And then our aliases will take effect. Okay, I've relaunched AutoCAD. I'll just go into a blank drawing by clicking here. And then I will type C and see how the autocomplete now says C is copy. Also, CI is circle. So you can use this method of using alias edit to change the abbreviations you use for your most frequently accessed commands. In this video, I'll show you how to access help, which is built into AutoCAD. The great thing about help is you can get lots of specific information, but the problem is you have to kind of know what you need to find out, and that can be a problem. So if you know the command that you are having trouble with, then you can look it up. But if you're not sure what command to use, then that's another story. So right up here, there's a search engine that you can use to query AutoCAD's built-in help system. So if I want to type in the word circle and then press enter, it will automatically open the page about circles. And you can then go to the circle command itself and read about its prompts and so on. This is really most useful when you want to look up a specific piece of information about an option that you just aren't quite understanding. But again, it's really only very limited in its usefulness because you have to know exactly what you're looking for. You can also get there just by typing the question mark. It's its own command, question mark, enter. It opens the help just the same. You can also, if you do it this way, you can filter the results so that you can get content just for a user, or if you're writing your own programs, you can get information for developers. So I just want to know how to use the rectangle command, and I can type that in here and get some information. In this video, you accessed product documentation and are able to access videos that ship with AutoCAD through this help system. In this video, I'll show you a few tricks for saving, backing up, and recovering damaged files. Let's go ahead and open a few files to get started here. Go up to the Open icon on the Quick Access toolbar and navigate to the Chapter 2 folder. Let's open Plumbing, Mechanical, and the Architectural Imperial Units drawing file. So to select them, I'm going to hold down the Control key and select those three items. Click Open, and they will appear here on different file tabs. You can take a look. Let's say I made a change to one of these files. For example, here I could erase. I'll click the Erase icon here, and I'll erase this chair. I'll click on it and press Enter. Now I'd like to save the drawing. I could click on this icon, and that would save it with the same name that it has now. Or I could click on this one to give it a new name. I'll choose Save As, and I'll call it 2 on the end of the file name like that. Save. Now, if I make another change, say I pan the drawing by holding down the mouse wheel and dragging, you'll see that a little asterisk appears after the file name to indicate that the file has changed. You could now save it. I could either click this icon up here to do that, or type QSave, or the keyboard shortcut QS. Also, you can press Control-S, so there's many different ways to do this. My favorite is just to type QS and press the spacebar with my thumb. That seems to be the fastest for me. AutoCAD will also automatically save the file after a few minutes, and you can control how long that is in the options. So let's go to the Application menu and click on Options and take a look at that. Under Open and Save, Right down here, you can choose to automatically save a copy of your drawing every 10 minutes or however many minutes you want. I find this to be a little bit disruptive because I can be working and then all of a sudden AutoCAD will pause for a second while it's saving a large file. I find this to be a little bit annoying, so I usually turn this off. But alternatively, you could increase the save interval to something like every half an hour, and maybe it wouldn't get in your way as much. You can also optionally create a backup copy of every file, and I have that on. So let me show you what happens when I save this. I'm going to press Control S to save, and I'll go over to the Windows Explorer, take a look at the file system here, and see what's happened on disk. So I have a new file, Architectural Imperial Units 2, that was created when I used Save As. And then the backup file was generated when I just typed QS. If you need to use this file, let's say this one gets corrupted or deleted, you just have to rename the file extension to DWG, and it will open as a regular drawing. This can be handy because you're doubly protected, but it takes up twice as much space on disk. So for that reason, I tend not to use this method. So if you don't want to automatically create a backup, you can go back to Options, and you can do that quickly by typing OP, Enter, and it will just turn off the backup file creation and the autosave feature. Of course, then you're running the risk of losing everything, but we still have yet another form of backup available to us through Autodesk 360. But that's only available if you sign in up here to the service. And then every time you save, a copy will be uploaded to the cloud. In some cases, you might need to recover a damaged drawing. There's a special command for that called recover. I'm going to type that in. Recover, enter, and I will select this damaged drawing file, open. It's taking a while to think about this and to analyze all of the objects in the drawing. And now it's found 2 errors. Who knows what they were, but thankfully they were fixed. So I can say close. If you experience some strange behavior in the program where a line, you know it exists, but it doesn't show up, for example, you can try recovering the file, and it might correct any error. Now this is rare. This only happens in big project files that take a lot of memory. So I just want to point this out so you have another technique to save your data. In the next video, you'll learn how to set the drawing units. In this video, I'll discuss units. One of the first things that you want to do before you get started drawing is select a system of units. Open the Architectural Imperial Units sample file from the Chapter 2 folder, and then type UN, enter for units. This drawing is currently set to architectural, which means the foot and inch system. The symbol of inches is the double quote here. The symbol for feet is this single quote. They're both on the same key next to the Enter key on the keyboard. You don't actually have to ever type in the inch symbol because AutoCAD is going to interpret a number like 18 as 18 inches. You could alternatively enter that as 1 foot 6. That's one single quote 6, and AutoCAD will interpret that as 18 inches, just the same. You also have these other choices for units. So let's say I was using the metric system. I would select decimal units in that case. Engineering units are actually based on feet and inches, but they use decimals. So if I wanted to say 18 inches in engineering units, I would say 1.5 feet. Fractional units are inches only, no feet, and these are used by cabinet makers, for example. Instead of saying 5 feet, they would just say 60. Scientific units have exponential notation, and these can be in any type of unit that you want. It could be parsecs for astronomers or angstroms for circuit designers or something. You just type E to indicate powers of 10. I'll leave this set to architectural for the time being, and I will select a precision. Now, AutoCAD is actually going to record everything with the highest level of precision internally, but you might want to round off that precision just to make it a little more human-friendly. It can be very confusing to know how many 2/56 of an inch something is. So I recommend that you round it off, say to the nearest 1/4 inch or something, if you're doing architectural work. Angular measure can have different units. Decimal degrees is the most common. You could alternatively use degrees, minutes, seconds, or some of these other units. The way that you measure angles is controlled down here under direction. The default in AutoCAD is east is 0 degrees. So going to the right is 0 degrees. Going straight up then would be 90 degrees. So the system works in a counterclockwise fashion by default. You could change that so that north was the base angle, and then 0 degrees would be straight up. And that's typically the direction that you want for surveyor's units. I'll leave this set to east. Again, you can set the precision for the angular measure, and you can check here if you want it to go the other way so that angles are measured clockwise rather than counterclockwise. When you create blocks, you have to choose what units they're using. So here's where you can select which units you want blocks to be converted into. So because I'm using architectural units, it makes sense to leave this as inches. If I was using decimal units, I could then change this to be centimeters or millimeters. Down here, you have choices for lighting, international, American, or generic. I'll go with American, inches, and architectural. Down here on the status bar, you have the ability to add units down here as a special choice. However, it only lets you select one of these 5 systems. It doesn't give you any other choices. So I really don't recommend that you do it this way, because then you can't control the precision or the angular units or anything else. In the next video, I'll show you how to convert a drawing from one system of units to another. In this video, I'll show you how to convert a drawing from one system of units to another. We will convert from feet and inches to centimeters and back again. Go ahead and open the Architectural Imperial Units sample file from the Chapter 2 folder. Before we change anything, I'd like to measure a distance in the plan. And I need to measure something that I already know the distance of. So I could measure, let's say, this sofa here. It's probably about 8 feet long or so. Let's just verify that by using this tool, Measure. I'll click on this icon, and then I'll click near the sofa, right about here and right about here. And you can see interactively the distance there. It's actually close to 6 feet. So let's just keep that in mind. I'll press Escape to cancel out of that command. Now I'm going to change the units. So I'll type UN, enter, and change the type from architectural to decimal. And then I'll set the precision to be 0.0. Also, when you're changing units, it makes sense to change the insertion scale, but this is different than the drawing units. This is the scale that you're going to insert blocks at, and we'll learn about blocks later, but this is different than the drawing units. The units are really what you say they are in your mind. So if I say these are millimeters, then they are. If I say they are kilometers, then they are. It really depends on what you're drawing. So in this case, because it's architecture, I'm going to say that 1 unit is 1 centimeter. I'll click OK. And the units have changed, but the drawing has not. Let's go ahead and measure that again. And I'll click 2 points about here and here. And it looks like it's about 72 units. So that would be 72 inches. Really, because that's 6 feet. So the drawing still has another missing piece, and that is the scale. So it's really not enough just to change the units. You also have to scale the drawing to really convert it from one system of units to the other. So to do that, I'm going to use the scale command, which is located right here on the Modify panel. I'll click that icon, and now it says Select Objects. Just as a shortcut, I'm going to type All, A-L-L, enter. It gets everything for sure. And it still says select objects because I can keep selecting more things, but I'm just going to go ahead and press enter again to get out of that mode. Now it says specify base point. You can see that by the cursor and also down here on the command line. The base point should be at the origin point of the coordinate system, which is 0, 0, 0 in x and 0 in y. So I'll type 0, press the tab key to go over to the y coordinate and press 0 again, and then enter. Now it says specify scale factor. So here's where we have to type in the conversion factor between inches and centimeters. So I happen to remember that 2.54 centimeters equals 1 inch. So I'm just going to type in 2.54, enter. That scales everything up by 254%, if you will. Everything's bigger. I need to zoom out in order to see the whole drawing. So I'll just rotate the wheel of my mouse, and then I will drag the wheel to pan, like that. And again, I'm going to measure this sofa over here. Now it's about 180 something, so it's much bigger, and that makes sense for centimeters. It's almost 2 meters long now. So this is like a reality check I always like to do. Does it make sense? Yes, it does. Okay, it looks like I've successfully converted the units. Okay, now let's say we want to go back. We're starting with this metric drawing, and we want to go back to imperial. So again, we have to change the units to the values they were before, architectural and inches here. Okay. And now I need to scale it in reverse. So how do you do that? It's a little bit more complicated, but not much. Again, you do scale, select objects, we'll type all, enter, and then enter again to get out of select mode. And then the base point, I'll type 0, tab, 0, enter. The scale factor, this time, I don't know. I don't have a calculator to calculate 1 divided by 2.54, but I'm sitting in front of a computer that has that function built into it. So I can ask AutoCAD to figure that out for me. So to do that, I'm going to type apostrophe CAL. That means use a calculator transparently on top of this command. So I'll press enter. And now the expression is going to be 1/2.54. That means 1 divided by 2.54. That's my conversion factor. I'll press enter, and everything got smaller. Let's just go ahead and verify the size of that sofa now. I'll use the measure command again. I'll click 2 points here, and it looks like it's about 6 feet. So we did it correctly. So there you have it. The way to convert a drawing from one system of units to another involves more than the units command. You also must scale the drawing. In this video, I'll discuss some program options and their scope. To understand what I mean, let's just dive right in. Open the mechanical sample file in the Chapter 2 folder and type OP Enter for options. Go to the Display tab here. Let's change an option that has global scope, that is, an option that affects the program as a whole. I'll change the color scheme from dark to light and click OK. This option remains active no matter which drawing you're in. Go ahead and open the plumbing sample file in the Chapter 2 folder. Sure enough, the interface remains light. I can go back into Options and change that back to dark. I actually prefer dark because it gives you less eye strain. I'll click Apply. Now, some of the options have this symbol next to them, and it means the current drawing. So if I change this option, for example, Apply Solid Fill, I'll uncheck it, and that's going to be specific to the drawing. That means it has drawing scope. I'll click OK. And in this case, this particular option is visible after we regenerate the drawing database. And so we just type in RE for regen and press Enter. And when everything is regenerated or recalculated, if you will, the fill inside these plumbing objects disappears. This option is specific to this drawing. If I go over to the mechanical drawing, I can Go ahead and check out the options again, and you'll see that yes, this is selected here. So it's specific to the drawing. So you have two flavors of options, the options that affect the whole program and the ones that affect specific drawings. And you can tell them apart simply by using that icon in the options dialog box. In the next video, you'll learn about drawing templates and how you can use them to create new drawings. In this video, I'll show you how to create a template so that you can pass along drawing-specific settings into future drawings that you create. Go ahead and click New, and you're prompted to select a template file. Select the standard AutoCAD.dwt file. T is for template. Incidentally, this folder is located deeply in the hierarchy of the user profile. I'm going to open this particular template, and that creates a new drawing, drawing 6. If we want to alter the template, we have to access it in a different way. We'll go to Open, and then choose Files of Type DWT from this drop-down. That takes us to that same folder where we can open that template file. The difference is evident here on the Drawing tab. We see AutoCAD DWT, and the previous one said Drawing 6. So now we know that we're actually in the template. Let's go ahead and turn off the grid and toggle off the UCS icon by going to the View tab of the ribbon. I would also like to turn off the View cube and go to the Home tab. And just so that you really understand how templates work, I'm going to create a circle right here in the middle of this space. And I'm doing that just to demonstrate this point, but you normally wouldn't create a circle in your template. This is just to show you that this information is passed on to the next drawing. Let's go ahead and save this with a unique name. So click Save As and rename this My Template.dwt. Save, and you can type in an optional description here. No grid, no UCS icon. Okay. So we've saved the template, and let's go ahead and close it. Now let's create a new drawing using the template. Click New, select My Template, and click OK. Open. Drawing 7 was created with the circle. Notice that there's no grid and no UCS icon. So basically, this is the workflow for creating a template in order to pass on specific information to the new drawings that you create. Of course, we don't want to have a circle in every drawing, so we'll go ahead and erase that from the template file. Let's go ahead and open My Template, erase, type E, enter, select the circle, and press enter again, save, and close. Just to test it out, we will create a new drawing, but this time let's click the New tab, and we can access the template in an alternative way right here by expanding the Templates area, scrolling down, and choosing My Template.dwt. And it created a new drawing called Drawing 8 that has those specific settings set up so that now you're ready to create a new drawing. So in this video, you learned the ins and outs of templates, and you created your own template. In this video, you will pan to change your point of view in a drawing. Open the architectural sample file in the Chapter 3 folder to begin. Pan is perhaps the simplest of all commands. It doesn't have any options. I'll show you the formal method of using this command first, and then I'll show you a shortcut, which I prefer. So the pan command can be executed simply by typing P, enter. The cursor changes to this hand symbol. Click and hold the left mouse button and drag to pan. When you're panning, what's happening is you're changing your point of view. you're not actually moving the geometry in space. It's an important distinction. If you wanted to move geometry in space, you would use the move command. Here we're transforming the entire drawing, if you will, because we're actually moving our camera that we're viewing the drawing through. So I'm just panning, looking at different things. It's very intuitive. Notice down here, right above the command line, it says press escape or enter to exit, or right-click to display shortcut menu. So there's 3 options listed here of how you can get out of the command. Escape is the universal way to cancel out of any command. So you just press escape and the command is done. You know it's done because it says type a command here on the command line. You're ready to do something different. I actually want to go right back into the pan command. This time, instead of typing P enter, I'm just going to press the space bar. The space bar works just like enter, and you can do this with any command. You can just repeat the previously issued command by pressing the space bar or enter. So it goes right back into the pan command. This time I can pan again. Maybe I'll go over here, check out what's over here. And I want to end the command again. This time I'll press the space bar. The command is done. Let's go and try it again. I'll press enter to repeat the previously used command. I can pan again. I'll go down here. And this time, I will use this last option, right-click to display shortcut menu. I'll right-click, and I see that I can switch to some other navigation commands, such as zoom, 3D orbit, or some of the zoom options, zoom window, and so on. In this case, I'm just going to exit, so I'm going to click on that option in the context menu, and the command is done. So there are many ways you've seen there to use the formal pan command. There's still another pan command, which is the older pan command, and you can access that by pressing -P. All of the older commands generally are still in AutoCAD, so this is great. If you learned it a long time ago, you can still use your methods. And this is also useful because some of the older commands have different options and some have advantages that you don't have in the latest command. So here we have -P for the original pan command, and it asks you to specify a base point or displacement. Basically, you need to click 2 points so that you can slide the drawing over from point A to point B. So I'm going to click a point for point A, and then I'll click another point over here for point B, and the drawing is slid over that far. So that's a little bit harder to use, I think, than simply dragging. So I just wanted to show you, though, that all of the older commands are there if you preface the command with a dash. Okay, now all of that you can kind of forget because my preferred way of panning is simply to drag the mouse wheel. Just hold down the mouse wheel and you'll see that the cursor changes to the closed hand symbol, and then move the cursor. And I'll do that again and again. You see, this way it's kind of a shortcut and it doesn't issue a command. You don't see anything change down here on the command line, and it works transparently on top of any other command that you may be in. So for example, I could be drawing a circle. I'll just click on circle, and then I'll click a center point here, and then I realize, oh, I actually want to make a really big circle and I don't have room for that. Well, I'm going to drag the mouse wheel over here, and I can pan while I'm doing something else. This is called a transparent use of a command because it's working in the background, if you will. So I can click right here to specify the radius of the circle, and the circle command is complete. And I can pan down here and see some of that circle. Now there's even one last way I can think of to pan in a drawing, and that is to use the scroll bars. And they're off by default here, but I'll just show that to you also. Type OP for options, enter, and then right here on the display tab, the first option, it's a checkbox, is to display the scroll bars. If we do that, we have a scroll bar over here on the side that you can use to pan. Now this is a really inefficient way to get around, I have to say, so I don't favor it. There you go. That gives you the sense of how AutoCAD works. There's so many different ways to do the same task. And you just have to kind of navigate through all these methods and find the one that works for you the best. For me, it's simply to drag the mouse wheel to pan the drawing. So in this video, we explored not only the pan command and its variations, but we got a little bit more familiar with how AutoCAD works with commands and how you can cancel commands and repeat commands using the Enter key or the space bar. In this video, I'll discuss the zoom command and many of its options. AutoCAD has the capacity to zoom in indefinitely without a loss of quality. This is in contrast to a program like Adobe Photoshop, which is a raster program. In a raster program, you zoom in and you'll find the pixels that the image is made of. In AutoCAD, when you zoom in, you just keep going. You never run into pixels. That's because AutoCAD is a vector program and it's fundamentally based on math. The math is what's behind these objects. A line is defined by its endpoints, and that means you can zoom in basically infinitely. You can keep going in or out. And that's why AutoCAD can be used for astrophysics all the way down to circuit design, very small things. Let's go ahead and open the architectural drawing in the Chapter 3 folder and go ahead and pan around the drawing by dragging the mouse wheel. My favorite method of zooming is to rotate the mouse wheel. I'm going to rotate the mouse wheel and zoom in. But notice what happens. I'm sort of getting lost in space. Everything is black. I'll zoom back out. With this method, the position of the cursor on the screen matters. If I put the cursor over here over the kitchen sink and rotate the mouse wheel, I'll zoom into the sink. If I zoom out here and reposition the cursor over this range, I can then zoom into that. It works dynamically, so where you put the mouse determines the center of the zoom operation. I'd like you to zoom in here in this lower left-hand corner of this range. Just keep zooming in. Eventually, you're going to find this tiny little object that I put in here, just to show you that we can get really close into this object and we can ultimately run into a wall. See, I can zoom in and then I seem to stop here. Now, this seems to contradict what I said earlier, that we can zoom in indefinitely. And we're stuck here until we learn about the regen command. If you regenerate the drawing at this point, you will sort of recalculate the math behind this representation, and that will allow you to zoom in more. So I'll type in RE for regen and press enter. Now the mathematics underlying this geometry have been re-normalized, if you will, at this point, and now I can keep zooming in. By the same token, if I zoom out, I'll run into a wall at some point where I can't go any further. Now I'm kind of stuck here, looking at this detail of the corner of the range. What happened to the whole floor plan? I want to see the whole thing now. Well, I can regenerate at this point again, and then I can keep zooming out. You can do that indefinitely. I can keep doing that, regen, and I can zoom out more and more, and I could keep doing this until the entire building was a single pixel on the screen. But I think you get the point. We can zoom in and out as much as we want. And if you run into a block like that, just regenerate, and then you can keep going. Now, that's my favorite way of zooming, is using the mouse wheel. But there's actually, the zoom command is the more formal way to do it. And it has certain advantages. Let's try it out. Type Z for zoom and press enter. Now this command has many different options. They're listed down here on the command line. There's also a default option in angled brackets here, real time, and it's also attached to the cursor, highlighted in blue. If you want to use the so-called default option, you press enter. Now we're in the real time option. The way that this works is you can zoom in by dragging up and zoom out by dragging down. Dragging left or right doesn't do anything. Now, unlike the mouse wheel method, This doesn't matter. It doesn't matter where the cursor is. I can put the cursor over here and zoom in, and it doesn't zoom in to that stair. It's just zooming into the center of the screen. So I don't prefer this method because you have to then pan by dragging the mouse wheel, and then you can continue. I'll right-click and choose Zoom, and then I can continue using that real-time option. But this takes a little bit more doing. I have to keep switching back and forth between pan and zoom. I'll press Escape to end the command, and then I'll press the spacebar to repeat the zoom command. Now I'd like to see the entire drawing fit on the screen. The way you do that is with Zoom Extents, and I can click this option right here to execute it. That's Zoom Extents. I see everything in the drawing. Now another useful zoom option is Zoom Window. I'll type Z, enter, and Zoom Window is actually already running. And I get a prompt for this option that says, specify corner of window, or enter a scale factor. So I'd like to zoom in to this chair right here. So to do that, I'm going to specify the corner of a window. You do that simply by clicking in the upper left-hand corner. And then it says specify opposite corner. I'll click down here in the lower right corner of the window. And I zoom in there. So the size of the window that you make determines how much you zoom in. Let's go zoom previous. I'll type Z, enter, and P, enter. I can use P because it is highlighted in blue on the option. So P will be equivalent to clicking on this option on the command line. This time I'll zoom into that tiny object on the range. I'll type Z, enter, and I'll use the window to zoom in really tightly here, and I do that by making a very small zoom window. I'll do that again by pressing enter to repeat the command, and then I'll zoom in there like that. And again, this is very small. Notice I didn't need to regenerate here. It says down here, regenerating model. It does it automatically when you're using the zoom window. There's a shortcut for using Zoom Extents, and that is to double-click the mouse wheel. Just double-click the mouse wheel and you Zoom Extents. It can be a little tricky because double-clicking the mouse wheel will sometimes also rotate the wheel, and it will jump like it's doing here. But that's a quick way of seeing everything in the drawing all at once, is to double-click the mouse wheel. The navigation bar can also be used to execute zoom options. You click this little arrow underneath the zoom icon to access this menu of zoom options. I can use Zoom Window. I'll zoom into this chair. And then let's go back to where we were before by using Zoom Previous. I'll select Zoom Previous. So this is yet another method for navigating a drawing. I prefer the mouse wheel approach, but it's good to know the different methods that you have at your command with Zoom. In the next video, you'll learn to navigate model space and paper space. In this video, you'll learn about the difference between model space and paper space, and how to navigate between model and layout views. Open the architectural sample file in the Chapter 3 folder, and go to the View tab. Let's turn on Layout tabs here. This displays these elements in the lower left-hand corner. Right now we're on the Model tab, and that means that we're in model space. This is the space where you will draw all of the objects that you work on in AutoCAD. When it comes time to present the design, you create a layout, and this represents a physical piece of paper. Whether or not you're actually going to create a physical output or an electronic form of output doesn't matter. The layout gives you a chance to compose that on a specific sized sheet. We can go there simply by clicking on the Layout tab. So click on Layout 1, and you'll see what we call paper space. This is laid out according to the dimensions of this sheet. Let's go to the Home tab and click the Measure tool here in the Utilities panel. I'll click 2 points roughly on the edges of the paper, right about here and over here. It says this is 3 feet wide by about 2 feet high. So this is a 24 by 36 standard sheet of paper. Now we're displaying our architectural plans here using a graphic scale. I'm going to zoom in there on this call out here, and it says it's in 1/4 inch scale. That means a 1/4 inch on the paper is equal to 1 foot in the real world. Over here we have a detail of the stair, and that's in 1 inch scale. So 1 inch on the paper is 1 foot in the real world. So everything here on this paper is in paper space. That is, it's measured within 2 by 3 feet. If I double click on this plan, it opens up the viewport. The viewport is like a window that I'm looking through into model space. So when I'm in here, in this viewport, I can then use the measure command, and I'm going to measure this table, just roughly, from about here down to here. Now it's over 12 feet. So clearly we're measuring a different kind of a space here. This is the model space. And model space is always in real world scale. That means the objects are the right size that they really are in the real world. It's the viewport that enables you to bridge between the real world and paper space. So I can double click out here on the paper to go back into paper space. And you know you're in paper space when you see this icon here, this triangle symbol. The cursor can also move all the way across the paper when you're in paper space. When you're in model space, you know it because the cursor is trapped within that viewport. You see? If I click over here on this viewport, I can go into that viewport, but again, the cursor is in there. If I come out of here, it changes to an arrow. So I'll double click right here to go into paper space. So we can go back and work on our drawing by switching back to the Model tab. And anything I do here, of course, will be represented faithfully in paper space because we're merely looking through a window in paper space into this space where we're actually modeling everything. Now, I'm going to go back up to the View tab and turn off the Layout tabs. I prefer now to use the File tabs to navigate between Model and Layout. I can just put the cursor over Layout 1, and I see a preview of that. I can put it over Model, and I see a preview of that. Every drawing has a model space, and you can have any number of layouts. So you can have 20 different pieces of paper, if you will, that are all referencing model space. To go into this layout, you just click on it. Now I'm in there. To go back to model space, you just click here. So it's very intuitive. You can also plot. I can plot this layout directly from this little icon here, and I can publish a whole set of sheets from this icon. So this is the method that you can use to navigate between the different spaces in every drawing. Views are like bookmarks in space. In this video, you will save and restore views of key places in a drawing. Open the mechanical sample file from the Chapter 3 folder and zoom in here on the top drawing. I'd like to save this as a view so that I could jump back here to the top view more efficiently. I'll type V, enter for view, and then click New. I'll give the name top, and I'll just leave everything with the default options. It's a still view. It's the current display. I can optionally save a layer snapshot with this view, and we'll just go ahead and click OK. OK again to close the View Manager. Now I'd like to zoom extents, and I'll do that by double-clicking the zoom wheel. And then I'll go ahead and pan by dragging the zoom wheel and zoom in down here on the front view. Maybe I'll zoom in a little more, and I want to be more accurate about that. So I'm going to type Z enter for zoom, and I will specify a zoom window by clicking its upper left corner and lower right corners like this. So now I'm zoomed in tight on the front view. So I'll type V enter for view, and I'll go ahead and create a new view called front. OK, and OK again. Now if I want to jump back to the top view, I can do that very easily by typing V enter, and then double click on top, and click OK. So in this way you can jump directly to the view in question. And of course, saving views becomes more significant in larger, more complex projects where you have a whole architectural campus, for example, or a big engineering drawing with lots of different components. You can name the views and jump right to what you're working on. You can also use the command line version of the view command without having to see the dialog box, and you can do that by typing -V for the older view command. It doesn't present you with a dialog box. Instead, you have options on the command line. So I'd like to restore a view name. And for this, you have to already know the name. So I do. I'm going to type in front and hit enter. And I go right there. Notice that it's not case sensitive. So I can just type in front all in lowercase, and that works fine. So let's try that again. I'll type -V, enter. R for restore, enter, and then top, enter. So this is an alternative way of navigating more complex drawings. In this video, you have saved and restored views to quickly jump to specific places in a drawing's model space. In this video, you will draw AutoCAD's most common objects, lines. To begin, let's go ahead and toggle off anything that's on in the status bar. This particular element here can't be turned off. It just tells us about our hardware acceleration. If you want, you can hide that by going to the Customization button here in the corner and turning off Graphics Performance. While you're here, also go ahead and turn on Dynamic Input. That opens up this control right here. I'd like to turn that off also, so that we can draw lines without distraction. Now go up to the Line tool here on the Draw panel and click. Now let's pay attention to what it says on the command line. It says Specify First Point. That just means click someplace on the screen. I'll click at some arbitrary point, and notice that the cursor appears to be connected to that point now. It's connected with what we call a rubber band line. The command line now says specify next point or undo. Undo is the option that we have. We can go back and specify the first point again. But we'll just move forward. I'll click another point. And the line command doesn't end. You can keep going, drawing lines. So I'm going to click another point. Notice now, however, that we have an additional option, close. This is available to us because we've drawn 2 line segments. I'll click that option, and the line command ends. We have now 3 different separate objects here. And I'd like to repeat the line command. So to do that, I'll press enter. I'll click a point. Click another point up above, another point, and this time to end the line command, I will right-click. That opens this shortcut menu. You have the options here, close and undo, just like you do down below, and you also have enter, so you can click right here. I'd like to show you an option that I like when I'm drawing lines. It's called time-sensitive right-click. And this just makes drawing lines a bit more efficient. To access this, we'll go into the Options dialog box. Type OP for Options and press Enter. Go to the User Preferences tab and click this button. To turn on this time-sensitive right-click, simply check this box. And what this does is it times you when you're right-clicking. If you right-click rather quickly, less than 250 milliseconds, then it will be equivalent to pressing the Enter key. If you take longer than that, it will open the shortcut menu. Apply and close, and OK. Let's try this out. Draw another line. Click a few points. And let's say we're done. Let's end the line command. Just right-click quickly. And the line command is finished. Now you can repeat the line command by right-clicking again. Draw a few more segments. Right-click. This time hold the right mouse button down for longer than 250 milliseconds. And what happens is you'll see that shortcut menu. I don't find this shortcut menu to be so useful. I prefer just to access the options down here on the command line. But, there are many different ways to do things in AutoCAD, so it's good to know what your options are. When you use time-sensitive right-click, you can actually draw very quickly. You can go line, click, 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 right-click again, and draw some other lines over here. Now let's toggle on dynamic input down here on the status bar. I'll pan over so we have some blank area to draw in. Draw another line, and notice what's different. Now we have these interactive elements appearing next to the cursor. The first highlighted number is the X value, and it gets larger when we move to the right, smaller when we move left. The Y value gets larger when we move up. If I click a point, it's going to specify the X and Y coordinates of that point, just like that. Now we have different controls. We have the length of the line relative to the first point, and we have the angle. 0 degrees is horizontal to the right. 90 degrees is vertically straight up. It's kind of hard to see that there. 90 degrees is straight up. If you go down below, this could be specified as a negative angle, or just by moving the cursor down, allows you to enter a value down here. So I could do 28 degrees down here, or 28 degrees up here. Let's say I wanted to draw a line that is 10 units long, that is horizontal. I'll type in 10 and press the Tab key. Now 10 is locked in, you see? There's a padlock symbol there, but I still can specify the angle. So I'll type in 0 and press Enter. So there's a line that's 10 units long, running horizontally. Now let's say I want a line that's 5 units long, running at a 45-degree angle. I'll type 5 Tab 45, Enter. Now I'll press Enter to end the command. Another useful aid that you have access to is Ortho, and it's right next to this dynamic input. Let's toggle that on, and it's really useful when you're drawing lines. Type L, Enter for line, and click your first point. This time, notice that the cursor is constrained horizontally or vertically. This will save you a bit of time because you don't have to type in the angle. I can type in 5, Enter, for a horizontal line. I can move the cursor up and type 5 here, 5, Enter. You can override Ortho by typing in an angle. So I can press Tab, go to the angle, and type in 45, Enter. If you want to specify the angle and the distance, you can do that, but you just have to use the Tab key. You can do it in either order. I can press Tab, say I want this at a 0-degree angle. I'll press Tab, and then I'll type 3 and press Enter. So that's how you can specify your lines pretty easily with Ortho. Now Ortho can be toggled on and off at any time while you're drawing lines. So I can draw some arbitrary length lines here. I'll turn Ortho back on, draw another few lines with Ortho, and to save time, you can also use the F8 key. So I'll press F8. Then I have the freedom to specify the angle. I'll press F8 again. That locks me into horizontal or vertical. And so in this way, you can draw in lines more efficiently. So in this video, we covered the ins and outs of drawing lines. And we also took a look at dynamic input and ortho modes. In this video, you will draw circles using a variety of different creation options. Let's begin with the command line interface only, so that we can focus on the command prompts. To do that, let's toggle off dynamic input. Then go ahead and type circle, or at least a portion of the word, and autocomplete will fill in the other letters. Then hit enter. The command line says specify center point for circle, and that's what we're going to do. It also says or, and it has a bunch of cryptic options that we'll get to later. But the first thing is the circle needs a center. So we can specify that by clicking a point on screen. Once we do that, the command moves on to the next step. It says specify radius of circle. We'll do that also interactively. And you can get really good feedback here where you see that there's a dashed yellow line connecting the cursor to the center point, and that is the radius. So we're interactively specifying that length just by the position of the cursor. Clicking again sets the radius of the circle, and it ends the command. Now this circle appears blocky. You can see that it's made of a number of line segments, and this highlights what's really happening behind the scenes, if you will, in AutoCAD. AutoCAD has to remember the center point of the circle and its radius, and that's all it really needs mathematically speaking. However, the representation of the circle can be approximated by a number of line segments. Now, geometrically, a circle is an infinite number of points equidistant from a center, but in the computer, it's going to have to approximate that with a number of straight line segments. And if we have enough, it will appear nice and smooth. Let's increase the smoothness by going into the options. Type OP, enter, and then we're going to increase this display resolution to the maximum value. In this case, it's 20,000. Boost that up, and then click OK. So now the circle appears nice and smooth. It's still composed of little line segments, 20,000 in fact. It used to be that this parameter was more important when computers were slower, but now it's really not a problem to display circles in this way. So I recommend that you boost up that parameter all the way to the maximum. Now let's create a few more circles. Pan over a bit, and we'll draw another circle. Type CI, enter. And this time we'll create a circle with a given size using a number. So we'll specify a center point at some arbitrary location on screen. Just click a point to specify that center. But now we can specify the radius of the circle using a number. I'll just type in 4, enter. Evidently that is a circle that is 4 units in radius. Now there's really no telling when you're starting a fresh drawing if that circle is going to be really small or really large, so you might have to zoom in or zoom out to see it on screen. Now I'll pan over again, and this time I'd like to ask you just to draw a few lines just like this. It doesn't matter how long they are or exactly what angle they are, but we just want to have 3 lines that sort of imply a kind of a triangle. And what we're going to do is fit a circle inside there. Now, we don't know where the center of that circle would be, but we can get AutoCAD to figure that out for us using one of its options. So we just go up here to the circle command and open it up, and then use this last option, 3 tangents. Now what happens is it simply executes the circle command, as you can see down on the command line, and it says right here 3P. So it executed this option. We could have done that manually, but this is just automating that a little bit by typing those things in for you. And it says specify first point on circle, tangent 2. And watch what happens if I move the cursor over here. A green symbol appears called a deferred tangent. What I need to do is click anywhere on that line. As long as that green symbol appears, I'm good. Just click right there. And AutoCAD knows that I'm trying to create a circle tangent to that line. Tangent means that the circle will pass through that line at only one point. Now, I'm going to go down here and make another deferred tangent. It's deferred because AutoCAD can't calculate where that point is yet. You have to specify all 3 lines, and then it will be able to calculate all 3 tangents. I need to come up here and click this line, and the circle is created. So the options are there because there are different geometric conditions that you have to work with. When you want circles to fit inside of certain areas, you need to choose the right option for the job. Let's try drawing another circle using the dynamic prompt. So let's toggle this mode on. And this time I'll type circle, enter, and we have some information there attached to the cursor. It says specify center point for circle or down arrow. I'll press the down arrow on the keyboard and it drops down a menu containing the same options that you see on the command line: 3-point, 2-point, and tangent, tangent radius. But here I can select them using the cursor. I'll do a 3-point circle, so I'll click right here. Now it says specify first point on circle. I'm just going to approximate this intersection point by eyeballing it. I'll just click right about there. And then second point on circle is going to be, I don't know, right about here where this line would intersect with that one. And then the third point is going to be over here about where those two would intersect. Now I'm intentionally estimating this, but there's a better way to do this using object snaps, and we'll cover that in a future video. I'm just going to click a point right about here to specify that third point. And then AutoCAD can calculate where the center of that circle would have to be. And the command is done. So there you have it. There are many different ways of drawing circles, and you just need to choose the options to suit the geometric situation. In this video, you will draw some arcs and explore some of the creation options available to you. Open the arc sample file in the Chapter 4 folder. It depicts the floor plan of a single room having a door and an opening. I'd like to create an arc in this area here that represents the way that the door closes. To do that, I will use one of the many options here in the arc flyout. In this particular situation, we have an arc which has a center point which is coincident with the door's hinge. So we should choose a creation method that accounts for a center. These 3 have center in their names, as do these 3. Now, the only difference between, say, this one, center, start, end, and this one, start, center, end, is simply the sequence of events. Let's try this option here, start, center, end. So I'm going to specify the start point of the arc right here. Now I'm using object snap to be precise, and I'll talk more about that later in a subsequent video. But suffice it to say, all you have to do is click here, and the arc will be precisely connected to that endpoint. Now the prompt says, specify center point of arc. So the center of this door swing is going to be the door hinge, and that's going to be right here. So click. And then you can see what's happening. The prompt has moved on, and now it says specify endpoint of arc. And I can click right here to specify that and end the command. So we've successfully created a door swing. Now what happens if you did this in a different order? Let's see what happens. Use the erase tool here on the modify panel. Select the arc and either press enter, press the space bar, or right click to complete the command. Now let's go ahead and draw the same type of arc, start, center, end. But this time, let's say that we start up here. Start. The center will be in the same location. And the end point will be over here. But look at the problem. The default method of creating arcs is counterclockwise. So the arc swings around that way. Well, that's kind of a problem because we didn't anticipate this when we were creating this arc. But that's okay, because if you read the command line, it says, specify end point of arc, but then it goes on and it says hold Control to switch direction. So that's what we're going to do. Hold down the Control key, keep holding it, and then you have to actually move the cursor a little bit to have it update. Then click in this location to specify the endpoint, and the arc command is complete. You can also draw arcs more or less freehand by specifying 3 points. That's this first option. Let's try that off to the side over here. I'll pan over. For this, we just need to click 3 points. 1, 2, 3. And the arc is complete. You can edit the curvature of that arc after it's created by selecting the object. That enables the object's grips. There's a grip here for the center point. When you position the cursor over it, it becomes a hot grip and it turns red. Click on that grip, and then you can stretch it or move it in space. I'll click again to put it back down. I can click any one of these grips and reposition it. This allows me to really control the curvature of this arc. But remember, arcs are really just parts of circles. So you can't create really complex curvature with an arc, but you could connect arcs together to create more interesting shapes. So for example, let's say I'm going to draw a line over here, like that, and then I'll follow that up with this last option, continue. This will create an arc tangent to the last line or arc drawn. So you see what's happening here? The arc maintains tangency with that line. So it has a nice curve joining in with that line. Now if I do that again, the next arc that I draw remains tangent to the previous arc. And so in this way I can make nice smooth shapes. Incidentally, you can use the blend command to join arcs which aren't connected. Let's try that just because I'm mentioning it. Blend, and then I'll select this arc, and it will try to blend there. It didn't do a very good job, but if you zoom in, you'll see that it actually is curved. But because this is such a sharp turn, it doesn't look so great. I'm going to erase that. And this time, I'm going to move this one over a little bit like this. And let's see what kind of a blend we get now. Blend. And I'll select these two objects. And we get a better curve. Now this blend curve is not an arc. It's a spline. So it has more complex curvature, as you can see there. Now another way you can create an arc is by trimming a circle. So I'm just going to go ahead and erase this arc. And I'll just show you yet another way that you can arrive at that nice door swing. You could create a circle which is centered here and continues to this point. Then you could trim the circle and thereby convert it into an arc. Again, you'll learn more about trim in a subsequent video, but I thought I would just show you this method. Up here, you'll find a flyout that contains trim and extend. Let's use trim. And trim works by selecting objects which act as cutting planes. So I'm going to select the door and this line, and then press Enter to move on to the next step. Now it says Select Object to Trim. I will click this part of the arc to trim it away. Now press Enter to end the command. So we've trimmed a circle and converted it into an arc. If I select this arc, you'll see its grips appear, and its center point is located right there perfectly on the hinge of the door. Press Escape to deselect the object grips. So there you have it, many different ways of creating arcs, as well as trimming circles to create arcs and blending between curves. In this video, you'll draw ellipses and elliptical arcs. The term ellipse refers to an oval shape. Open the ellipse sample file from the Chapter 4 folder. This file contains 2 lines and 2 point objects. Incidentally, you can create point objects with the point command. Just type PO, enter, and click a point to create a point. There are no options. It's a very simple command. It makes a placeholder that remains as a single pixel. No matter how much you zoom in on it, it doesn't get any bigger. So I've used these 2 points up here so that you can snap ellipses to them. So I'm going to delete this new point object by selecting it and pressing the delete key. So let's type in ellipse. I type ELL and autocomplete does the rest. I'll press enter. And now the command prompt says specify axis endpoint. So an ellipse is defined by 2 cross axes. There's a major axis and a minor axis. In this case, I'd like to draw an ellipse so that the major axis goes across here horizontally and the minor axis runs this way vertically. So the axis endpoint would be right here. And a green box is showing up because I turned on endpoint object snap down here. This is on. And you can see that endpoint, node, and quadrant snaps are running. This will allow me to snap the ellipse to this geometry that we have in the sample file. So we're going to specify the axis endpoint right here by clicking. And now it says specify other endpoint of axis. That will be way over here on this line. Now it says specify distance to other axis. I'll click right here and the command is completed. Let's try that in a different way. Click on the ellipse and press delete. This time, let's try the center method. It asks us for the center first. Click here. The point has a node snap. And then we'll specify the endpoint of the axis over here. Now this is actually the half axis. The distance from the center to the end of the major axis is half of the axis. And similarly, the minor axis is the distance from the center point to the point you click. And this is all very obvious because it's shown to you with the cursor. You can see what you're going to get before you get it. The elliptical arc works in a similar way. It's simply an ellipse that's been trimmed so that it's just a part of an ellipse. So here, we're going to specify the axis endpoint or the center. I'll choose the center option, so I'll press the down arrow and choose center. And I'll click right here. And then again, the endpoint of the axis, I can go here or here. It doesn't matter which one. I'll click this right here this time. Now, specify the distance to the other axis. That will be right here. So it looks the same as the original ellipse so far, but we have a couple of other steps. We can specify the start angle. So for that, I'm going to click this point over here as the place I'm starting from. And then I'll turn off ortho by pressing the F8 key. And you can see that we have the ability to draw an ellipse all the way around here as far as we want. I'll press F8 again, and that will constrain the angle that I can use from 90 degrees to 180 degrees to 270 degrees. In this case, I just want to go over here, so I'll click anywhere on this line. It doesn't matter where. I don't have to snap to this endpoint. I can just click right here, and the command is done. So there you have it, several different ways of creating ellipses and elliptical arcs. In the next video, you'll draw more complex curves with the spline command. Splines are used to create complex curves. In this video, you will use 2 different methods to shape splines. Open the map sample file from the Chapter 4 folder. Here you'll find a map of Maui, Hawaii. It's attached as an image file. If you zoom in, you'll see the JPEG compression artifacts here. Our task is to trace some of the outline of the island with splines. This way we could create a vector representation of the island for use as a project site plan. Say the project is located at this dot, and we'd like to show the outline of the island to give the viewer of the drawing a sense of context. I'm going to zoom in here on this area right here where we have a lot of curvature. And let's try drawing our first spline. Click the Draw slide out, and you'll see two spline tools located right here, Spline Fit and Spline CV. CV stands for Control Vertex. Let's start with the Fit method first. Click this button, and it says Specify First Point. I'm just going to click a point somewhere along this path. Don't worry if you don't find the exact same place on the island's coast. It really doesn't matter. The point here is just to trace some of the island to get a feeling for the spline tool. Enter the next point. I'll click here and keep going. Each time I click, I'm adding a new fit point that lies on the spline curve. You don't have to get it perfect the first time around. You can just sort of estimate. If you zoom out some more, you'll get a better view of the whole island, and you can just go ahead and click some points. When you're ready, just go ahead and click Enter to finish the command. There's no need to trace the entire island unless you just want the practice. I'm going to zoom in here and show you how you can edit the shape of the spline after it's been created. Simply click on the spline to turn on its grips. Then you can click on a grip and stretch it. Now, things that often get in the way of this are ortho or polar modes. If you have either of these on in the status bar, you can toggle them off. Also, you should turn off any object snaps that are running, because you don't want this to snap to something. You just want to change the shape of the spline by moving these around. Let's say I want to have the curve come in a little bit here more. It's hard to do that because I don't have enough control over it. What I can do in this situation is position the cursor over this grip, and then this menu appears. I'll choose Add Fit Point, and I'll click right here, and it creates a new grip, or fit point as it's called. I'll add another one, and in this way you can add additional curvature. You can also remove fit points that you don't think are necessary. Maybe this one we can get rid of. No, that kind of messed up the shape. Let's go back and add a new one right about here. So it's pretty straightforward. I'm going to press Escape to deselect the spline. Another thing you can do is turn on line weight here. And if you don't see this, you can go to the Customization button and toggle on line weight from the menu. Line weight is going to make the spline fatter so that it looks a little bit more forgiving at a larger scale. If you zoom out here, it looks really good from this vantage point. Of course, the closer in you get, the more discrepancy there's going to be between the spline and the coastline. Now let's go over here, maybe on the other side of the island, and we'll draw another type of spline object. Click the Draw slide out and create a spline CV. Now this method arguably gives you more control over the shape of the spline, but it's very different. You don't specify the points on the spline except for the first and last points. I'll click right here for the first point, and then the next point isn't necessarily going to be on the curve that I'm trying to trace. Maybe it will be over here, and then the next point down here, and so on. This will become clear in a moment when I end this and edit the spline. I'm just going to draw a little bit more though first. Okay, I'm going to stop here and press Enter to end the command. Now when I select the spline object, you'll see this lattice appear between the control vertices, or CVs as they're known. So these points aren't necessarily on the spline. As I said, the first and last points are, but all the other ones can be outside of the spline. This gives you the ability to affect the curvature with a little bit more finesse. And similar to the fit point method, you can add or remove these points from the menu. I'll add a vertex here And then I'll just go ahead and move these vertices around until it matches the coastline a little bit better. So this should give you a little bit of practice for tracing an image. Also, you can use this grip here, this special triangular grip has a menu associated with it. If you click it, you can then convert between the two types. If I convert this to a fit spline, the shape remains the same, but now we have points that lie on the curve. And similarly, over here, we can select this object, and it has a special grip menu we can use to convert it to a control vertices method, and then we can use these to sculpt the shape of the spline. So there you have it, several different ways of shaping splines to match the curvature of a map attached as an image. I'm going to discuss polylines in this video. As the name suggests, polylines are many segmented lines that behave as single objects. Before we create a polyline, let's start by drawing a few line segments with the line command. Click line, and simply click a few points on screen, like so. Right-click to end the line command. Now let's follow this up with the polyline command. It works very much the same way. I can specify points, just like this. You might notice that there are more options on the command line, and we'll get to some of those in due course. I'll right-click to end the command. So visually they look very much the same, but they're handled a bit differently. This is a single object. You can see that because the whole object highlights. These are individual line segments which are separate objects. Let's move. So click the Move tool in the Modify panel and select this line segment and this one. Press Enter to exit Select Objects mode, and then you'll need to specify a base point, which can be anywhere on the screen. This will be the point from which we are starting the move. And then we'll specify the second point. This is where we're going to put these objects. I'll click over here. So basically in the move command, we had to specify a point A and a point B to move the objects. And you can see what happened. The individual line segment moved separately from its cousins that were next to it, if you will. Now, polylines have that benefit of being a little bit more organized because objects that are similar can be connected together in a single polyline. But there's more to it than that. The polyline icon sort of suggests something here that's happening, and that is that you can create straight lines and arc segments with polylines, or any combination of them. So let's do that next. I'm going to pan down here so we have a blank slate. Then I'll draw another polyline. I'll specify a start point here. And then for the next point, I'll just click an arbitrary point like that. And for the next step, I will use one of the options. I'll press the down arrow and choose arc. You can see what's happening here. I have an arc that I can create tangent to the line that I've drawn. I'll click a point and go on to the next step. I can continue drawing arcs if I wish, or I can switch back to drawing lines with the line option. I'll come down here and click line to switch back into that mode. Now, when I do that, I have no tangency anymore to that arc. So I could kind of eyeball it, but that's not really going to be tangent. I'm just going to click over here, and there'll be a corner right up there. I'll go around and click a few more lines. Then I'll switch into arc mode, and I'll click close, and that will close the polyline with an arc. So this is still one object. If you click on the object after you've completed the polyline command, you can then edit its shape. using these vertices. I can move this around, and everything connected to that vertex is going to transform. Alternatively, I can use this middle grip, and I can add a vertex. I can do that as many times as I need to shape the polyline. You can also convert straight line segments into arcs, like this. Or you can go the other way. You can take an existing arc and convert it into a line. I'll press Escape to deselect. Now, polylines can also have width. Let's see how that looks next. Do polyline again. Specify a start point over here. And let's use the width option. I'll press the down arrow and select that here. It says specify starting width. I'll type 0.2, enter. And now it says specify ending width. I'll type 1, enter. So what's happening here is I'm creating some thickness on this line, and it starts from a narrow thickness and it ramps up to a wider thickness. If I click another point, it's going to continue with that ending thickness. In this case, 1 unit. I'll press enter to end the command, and those gaps between the segments are filled in. This is still a single polyline, and its vertices run right down the middle of that shape. Now, I want to draw another polyline, but if I do that, you'll see that the width is still in there. What if I want to draw a polyline with no width? Well, for that, I need to reset the values back to 0. So I'll type PL, which is short for polyline, or P-line as it's known. I'll specify a start point, and then click width, 0, enter, and then 0 again, enter. That will clear out the width so that I can draw polylines that have the minimum thickness, which is a single pixel. No matter how much I zoom in on that polyline, it will remain with a single pixel width because it's mathematically defined as the points that I've clicked with lines connecting them. So in this video, you've learned many different ways you can use polylines to create objects that are all connected, that may have straight and or arced segments with optional width factors. This video is about rectangles and polygons, two specialized polyline tools. You can find both of them on this flyout. We'll begin with the rectangle. As the icon suggests, rectangles are made by clicking two opposite corner points. I'll do that here. Very straightforward. I'll select the rectangle, and you'll see that it's actually a polyline. That means that we have access to its grips, just as if we had drawn this using the P-line command. We can then reposition these vertices if we want, or convert straight lines into arcs, and so on. So I'll press Escape to deselect. Let's try rectangle again, and this time we'll use a different option. Let's try fillet, this option here. Some people say fillet, I say fillet. The fillet is a radiused transition between each edge. So we're going to specify that distance here. I'll type in 1, enter, and then I'll go ahead and proceed to draw the rectangle. And you'll see what's happening here. We're creating a rounded rectangle. What used to be a corner is now this filleted radiused transition. This option is sticky. That means it persists. So if I create another rectangle, which I'll do by pressing the space bar, it's going to have that same fillet radius built in. If I want to set that back to get rid of it, I have to set the fillet radius to 0. So I'll do that next. Press the space bar and the down arrow, choose fillet, type 0, enter. And now just to show you that it's cleared out, I'll draw another rectangle. Let's try the chamfer option next. It requires the input of two different distances. Let's try 1 and 1 again, so that they're equidistant. Now, draw the rectangle. So what we have here is a beveled edge. The two distances are the vertical distance and the horizontal distance. I set them equal so that we would get a 45-degree bevel. This is also sticky, so if I draw another rectangle, it's going to have that setting on. So let's just go back and reset that. I'll go to chamfer and set the two distances to 0 and 0. Just like the P-line command, you can create rectangles that have width. I'll use the width option, and I'll set the width to 1. This creates a fat rectangle. And again, the value is sticky. I need to go back and reset width to 0 if I want to clear that out. Let's try drawing some polygons next. Polygons have equal length sides, so you can create things like triangles, squares, pentagons, hexagons, and so on. Let's try drawing a square. The number of sides is 4. I'll press Enter to accept that as the default. Now it says specify center of polygon. I'll just click a point. And then you have an option whether you want that to be inscribed within a circle or circumscribed about the circle. That means outside of it. I'll take the default inscribed in circle by pressing Enter. Now you can see what's happening. I'm drawing this square, and there's an imaginary circle that is surrounding it. And so we're specifying the radius of that circle right now. You can use ortho by pressing F8 to make sure that this is locked into a vertical orientation. If you go over here, you can do that horizontally, but the result is the same. You're creating a sort of diamond shape. Let's try that again with 4 sides, but this time I'll press the down arrow and use this single option called edge. This allows us to specify the edge length, and that's done by clicking 2 points. I'll click the first endpoint of the